Hey everyone! So, let's talk about something fundamental. Almost every single Java application out there needs to get data from somewhere, right? But how does that actually work? Today we're going to pull back the curtain and demystify the essential bridge that makes it all happen, JDBC.
It really all boils down to this one simple question. You spent all this time building an amazing Java application, but the lifeblood of that app, the data, is locked away inside a database. So how do you connect the two? How does your application ask for, and more importantly get, the information it needs to do its job?
The problem, when you get right down to it, is a language barrier. I mean, think about it. Your application is fluent in Java, but databases like MySQL, Oracle, or SQL Server, they speak a completely different language, SQL. So to get them talking, we need some kind of intermediary, a universal translator that understands both sides perfectly.
So let's put an official name on this. We'll call it Java's data disconnect. It's this built-in separation between how Java code thinks and operates and the totally different world of how relational databases structure and store information.
Here's a simple way to picture it. Over on one side, you have your Java app. It thinks in objects, methods, and classes. And on the other side, you've got the database, which is all about tables, rows, and columns. One desperately needs the data, the other one has the data, but they have no common language to make that exchange happen. See the problem?
And this is where our hero finally steps onto the stage. The solution to this whole communication mess is a really elegant and powerful standard called JDBC. This is the universal translator we've been looking for.
Okay, now this is probably the most important thing to get your head around. JDBC, which stands for Java Database Connectivity, it's not some program you download and run. It's a standard API, an application programming interface. What does that mean? It means it sets out a consistent, predictable set of rules. It lets you, the developer, write one piece of code to talk to pretty much any database, and you don't have to worry about the nitty-gritty details of each one.
So to really appreciate how JDBC works its magic, we need to peek under the hood a little bit. Let's take a look at its architecture. Think of this as the blueprint for how this whole translation process is put together.
Everything starts with the JDBC API. This is the top layer, the part that you, as the developer, are actually going to see and use in your code. It's just a collection of familiar-looking classes and interfaces, like connection and statement, that give you the commands you need.
Okay, next up we have the brains of the operation, the driver manager. A good way to think of it is like an expedition leader, or maybe a switchboard operator. When your application says, hey, I need to talk to that MySQL database over there, the driver manager looks at all the translators it knows about and picks the exact right one for that specific job.
And that brings us to the most specialized piece of the puzzle, the JDBC driver itself. This is that local translator. You're going to have one specific driver for MySQL, a totally different one for Oracle, and another for PostgreSQL. Each driver is an expert. It knows exactly how to take the standard JDBC commands your app sends and translate them into the native language that its particular database understands.
All right, so this diagram really ties it all together. Let's just follow the flow from the top down. Your Java application uses the standard JDBC API. That API call goes to the central hub, the JDBC driver manager. You can see it right there in the middle, acting like a traffic cop. Then it intelligently selects the correct specific driver for the database you're trying to reach, and that driver does the final specialized translation. It's a really clean, layered system.
Now, not all drivers are built the same way. Over the years, 4 main types have evolved. The really early ones, like Type 1, they were slow. They had to translate JDBC calls into another standard, and it just added a lot of overhead. But today, the modern standard, the one you're almost always going to use, is the Type 4 thin driver. Why? Because it's written in pure Java and it talks directly to the database. This makes it platform independent, which is a huge deal. It means your Java code can run on your laptop or in a cloud server or anywhere else without needing any special software installed. It's just the fastest and most flexible option, hands down.
Okay, so the theory and the architecture are great, but how do you actually use this stuff in your code? Well, it turns out it's a pretty clear 5-step workflow pretty much every time. Let's walk through it.
Seriously? Anytime you interact with a database using JDBC, you're going to follow this exact same 5-step recipe. First, you load the driver. Then, you open a live connection. Once you're connected, you create a statement object to hold your command, you execute that command, and finally, you process whatever results come back. Simple as that. Let's look at each one.
All right, step 1, loading the driver. This little line of code basically tells Java's brain, the JVM, to go find and initialize the MySQL driver class. This is what registers the translator with the main driver manager. Now, a little side note, modern versions of JDBC can often do this automatically, but it's still really important to understand what's happening behind the scenes.
Step 2, we make the call. We use the driver manager to get a connection. And we have to give it 3 critical pieces of information: a special URL that acts as the database's address, a username, and a password. If all that info is correct, the driver manager finds the right driver, opens up a live communication channel, and hands you back a connection object. That object is your ticket in. It represents your active session.
Okay, you've got a live connection. Now you need something to send your SQL command in. So you take that connection object you just got and you call create statement on it. The statement object it gives you back, think of it like an empty vessel, a container that's just waiting for you to put your SQL query inside of it.
And step 4 is where the action happens. We take our statement object, call execute query, and we pass in the actual SQL command as a string. The driver zips that command over to the database runs it, and then it sends the data it found back to us, all neatly packaged up inside a special object called a ResultSet.
And finally, we have to actually do something with the data we got back. That result set contains all the rows that our query returned. The standard way to go through them is with a simple while loop. The rs.next part moves a pointer to the next row of data, and as long as there is a next row, the loop continues. And inside that loop, you can pull out the values you need from each column.
So what we just saw was the happy path, right? Everything works perfectly. But in the real world, you've got to know how to handle the data that comes back. And just as important, you need a plan for when things go wrong.
Let's take a closer look at that result set. It's not just a big blob of data, it's smarter than that. It's an iterator with a cursor or a pointer. As we saw, the next method moves that cursor one row at a time. Once you're on a row, you can use methods like getString or getInt to pull data out of specific columns. And this is super important. When you're all done, you have to call close to release the resources on the database.
But what happens if something goes wrong? A bad password, the network goes down, a typo in your SQL query? Database operations can be fragile. That's why every single piece of JDBC code you write should be wrapped in a try-catch block. If an error happens, JDBC throws a very specific error called an SQLException. Catching it is what lets your program handle the problem gracefully instead of just crashing and burning.
So there you have it. We've demystified that critical bridge between the world of Java and the world of data. You've seen the architecture, you know the 5-step workflow, and you know the right way to handle results and errors. JDBC isn't just some abstract theory. It is the practical, rock-solid foundation for almost every data-driven Java application out there. So, now that you understand the bridge, the only question left is, what are you going to build with it?